Hello everyone, welcome you all. So in this video we are going to discuss some of the problems which are frequently asked upon the bipolar junction transistors. Okay, that is BJT. So the first problem is solve the below circuit. Okay, so they have given a circuit and asked to find out the following parameters, and those are base current, collector to emitter voltage, and then emitter voltage, base voltage. This is stability factor. Okay, so they have given one parameter, that is beta equal to 90. Okay, so this is base, this is emitter, and this is collector. Here you should note that the collector voltage is 0 because it is directly connected to the ground. Okay, so the negative voltage applied to the emitter and base terminals is minus 20 volt. Emitter resistance is 2k and base resistance is 200k. Okay, now we should note that whenever we want to find out the currents, first we should apply KVL to the base loop, and there we will be getting currents, and if we want to find out the voltages, then we should use KVL at the collector. So if you apply KVL to base, we will be getting currents. If you apply KVL to collector, we will be getting the voltages. So now first we will try to find out currents. So apply KVL to base loop, that is this circuit. So I have drawn this much, 200k, 2k, base, emitter, and collector part I have left because we need only base. Okay, so apply KVL. Right, the current direction will be from this to this because this is positive and this is negative. So current always flows from positive terminal to negative terminal. So this is positive and the current will go like this. Okay, so from base it will be entering towards the emitter. So first start from here, IB. So if you are moving in the direction of current, then we will take minus. So KVL is minus IB into 200 into minus the voltage between base and emitter will be inbuilt voltage, that is VBE. So this is not shown explicitly, but it is assumed that whenever you are using a BJT, that is the voltage between base and emitter exists, that is given by VBE. So this is standard value, 0.7 for silicon transistor and 0.3 for or 0.2 for germanium transistor. So you should note that this value is not given anywhere. So if they have given explicitly, then we have to consider that one. So if they have not given any value, then we have to take it as 0.7 because we assume that we are using a silicon transistor because it is cheap and it is easy to manufacture, right? So that's all about the theory part. Now coming to equation, minus VBE minus 2k into, so this I have written as, so the current which is flowing in this path will be IE because this is a emitter. So relation between IE will be equal to 1 plus beta into IB. Alright, so this relation is there between IE and IB. So I want to write IE in terms of IB. That's why I have written I1 plus beta into IB. So this I have written here into the resistance is 2k plus. So whenever you get minus terminal, you have to take a second terminal here because we are moving in the direction of current. So plus 20 equal to 0. Now substitute beta here, then solve for IB in the calc. We will be getting IB equal to 50.50 microampere. Okay, so now we have got base current. So we know this relation, beta equal to, that is current gain is output current by input current. So output current is IC, input is IB. So IC I can write beta into IB. So it will be equal to 90 into 50.50 10 to the power minus 6. So when you solve, it will be equal to 4.5 milliamps. So now we have got collector current as well. Now we have got IB, we have got IC. Now we need to find out the voltages. So to find voltages, as I have said, we need to apply the KVL at collector loop. So this is the circuit where the base has been removed. So I have not written the base as we need only the collector part. So this is the circuit. Apply KVL to the collector loop. So collector loop, if you apply KVL, so I will start from here. Okay, so start from here, move in this direction. Okay, so minus VCE, so we are moving in this direction, that's why minus VCE minus, this is emitter current IE into 2k plus, so second terminal is plus 20 equal to 0. Okay, so I is 1 plus beta into IB, so IB we know, we substitute from the previous value IB, then we will be getting VC equal to 10.82 volt. So now we have got VC. Now again to find VE and VB, so VE and VB are the terms which you need to find out in the next step. So we know the relation VC equal to VC minus VE. So this is nothing but if there are 2 points VC and VE, so the voltage between them will be VCE. So the voltage is the difference between VC and VE. So if you are moving from this end to this end, okay. So VC minus VED is will be equal to VCE. So VC minus VE will be the difference between these two voltages will be VCE. So VC minus VE equal to VC, we have find out 10.82. So we are trying to find this voltage, right? So VC will be equal to, VC is 0 volt, because here we will be having the VC and here we will be having the VE, right? So VC is directly connected to the ground here, so this is the ground terminal, that's why its potential will be 0 volt, and we will be having some voltage which we have found previously. So 0 minus V will be equal to 10.82. So it should be noted that VC is directly connected to the ground, that's why we are taking it as 0. Again V will be equal to minus 10.82. So now we have found out VE. Now again we need VB. So to find VB, we know that relation VBE, that is base and emitter voltage will be equal to VB minus VE. So we know VB equal to, so VB is standard value is 0.7 volt. So 0.7 plus VE, so V is minus 10.2. So when you add them, we'll be getting minus 10.12 volt as the base voltage. So that is the voltage at this point. Okay, so like this, with the help of KVL to the collector loop, we can find out the VCE, VE and VB values. So once you find out VE, we will be getting VE and VB easily, because we need to take VCE and VBE. So there we substitute these two values and we will be getting directly the output voltage at emitter and output voltage at base. Now coming to next part, that is to find the stability factor for the given problem. So this is the standard formula which we should use. So what is formula? 1 plus beta divided by 1 minus beta into minus RE divided by RB plus RE. So all the values we are knowing, beta we know, RE we know, RB we know. So substitute all those things and put it in calcium, we will be getting 48.12 as the stability factor. So we don't have any unit for this, because it is a stability factor. The units which you are getting ohm, there will be cancelling to each other, that's why we will be not getting any unit for this. Okay, so now coming to second problem of this session. So in the second problem, the problem is find alpha rating of transistor and also determine value of IC using both alpha and beta. So they have given a transistor and they have asked to find out IC using both alpha and beta. So they have asked to find out alpha as well. Okay, so the given transistor is 240 milliamp is the base current, and emitter current is 12 milliampere, and beta value is 49. Collector current we need to find out. Okay, all right, so this is the notch here: emitter, base and collector. So we know the relation between alpha and beta. Alpha equal to beta divided by 1 plus beta. So another relation is beta equal to alpha divided by 1 minus alpha. So if you know one, then you can find out the other easily. So alpha equal to beta divided by 1 plus beta. So beta they have given 49 divided by 49 plus 150. So it will be 0.98. Now to find IC, so they have told to use both alpha and beta. So first using beta I will find out. So IC equal to beta by IB. So this relation we know that output current by input current equal to beta. So that's why so this is actual relation is beta equal to output by input. So this is the output current, that is collector current, and this is the base current, that is input current. So current gain is always output current by input current. So IC I can write beta into IB. So this will be equal to 49 into 240. So plug in those values, then you will be getting 11.76 milliamps. Okay, so this is the collector current. Now using alpha, so here we have used beta, now we need to use alpha. So what is the relation? So alpha is also collector current. So this is for common base, so CB configuration, and this is for common emitter. So here we will be having output current by input current. So in case of common emitter, we will be having collector as the output and emitter as the input, because it is a common emitter. So there the input is applied between collector and the input is applied between base and emitter, and output is taken across collector and emitter. So that's why here we will be having alpha equal to IC by IE. So I can write IC equal to alpha into IE. So these two equations you should know in order to calculate this. So 0.98 into 12 into 10 to the power minus 3, so which will be equal to 11.76 milliamps. So this is how, using alpha and beta, you can find out the IC value once they have provided with 49, that is beta value. Alright, so now move to the next problem. So the next problem is find for the given circuit, determine VCE and IB if alpha equal to 0.96. So they have given a circuit and they are asking what is the voltage between collector and emitter and the base current IB. So they have given the value alpha equal to 0.96. Alright, so this is the common emitter configuration, where emitter is the input is between base and emitter, output is taken collector and emitter. Okay, so that's why they have given alpha here. So as I shown previously, if this is a common emitter configuration, they will be given alpha, so we need to use the alpha relation. So this is the best example for the previous equation, right? So alright, the given circuit is, so VBB is the base voltage, VCC is the collector voltage, which is 8 volt, and drop across this RC circuit, that is resistance is 0.5 volt, and the value of RC is 800 ohm. Alright, so the current which is flowing in this direction is IC, from the base is IB, and the voltage between collector and emitter is denoted as VCE. Alright, so I need to find out VCE, right? So I will apply KCL for the collector loop. Okay, so when I apply KCL, I will start from this point. So the current is flowing from positive to negative, right? So this will be in the direction, right? So I have denoted already here. So IC. So we are moving in the direction of current minus VCE. So this voltage plus second sign plus 8 volt minus, so this I have taken as 0.5 because they have directly given the voltage here. So this is positive and this is negative, so I have to take second sign, so minus 0.5 equal to 0. So when I substitute this value, VC equal to 8 minus 0.5, so rearranging the terms, VC will be equal to 7.5. Alright, now we have got the voltage between collector and emitter. So beta relation, so we know the beta relation, alpha divided by 1 minus alpha. So I will be finding beta as 24 here. So alpha value they have given 0.96, so substitute this and we will be getting 24 as the beta value. Now they have asked to find out the beta value, IB, that is base current. So first I will try to find out so IC equal to beta into IB. So what is IC here? IC equal to 0.5 divided by 800. So this is 0.5. So I equal to V by R. So we know this relation, right? So IC equal to beta into IB, we know the formula, but we don't know IC. So how I can find out the IC? IC I can find out from here. So the current flowing in this will be IC, and they have given the resistance and voltage. So I equal to V by R, voltage across it is 0.5 and resistance is 800 ohm. So this gives me is the current value, that is IC, which is equal to beta value is 24 into IB. So from this I can find out IB equal to 0.026 milliamps. Okay, so now I have got the IB value. Now to find out IC, so they have not asked about IC, but you can find out, so it's a good practice to do some extra work. All right, so IC equal to alpha into IE. So we know the relation alpha equal to IC by IE, right? So IC will be equal to alpha into IE, so output current by input current. So alpha equal to, so IC is 0.5 divided by 800 into alpha is 0.96 into IE. So IE will be equal to 0.65 milliamps. Alright, so this is how we can find out VCE and IB. So as well as IC you can find out, IE you can find out, though they are not asked in this problem. Okay, now coming to next problem. So Basically this is not a problem, so this is some theory part which I need to explain, because we will be facing many problems in remembering the current gain and voltage gain, right? So this is common base, common emitter and common collector configuration, right? So for common base, so the base and collector current, so input is the base and output is the collector. So this is having, so two terminals will be left, emitter and base we need to connect. Okay, so we have connected here collector, so I need to connect it base, because base should be common. So common base means opposite we will be getting bases here, so two bases will be there. Common emitter means two common emitters will be there. Common collector means two collectors will be there. So for all these things, base is the input and collector is the output. Base is the input and collector is the output. Base is the input and collector is the output. Okay, so the alpha, that is current gain for the common base configuration, will be output current by input current. So output current is IC, input current is IE. So base is common, that's why we don't write for base. Okay, so voltage gain denoted by GM, which is equal to output voltage by input voltage. So output current into output resistance, IC into R0, divided by input current into input resistance, so IE into RL. So we can write it as RI. So this is Ri, input resistance, this is output resistance. Okay, so this is current gain, this is voltage gain for common base configuration. So if though it is any configuration, first we need to consider base and collector as the input and output. So base is input, collector is output. So it is common base means we will be having another base this side, so the left terminal is emitter. So if you remember this trick, it will be easy to write the various expressions. So now coming to common emitter configuration, so here also base and collector you need to connect it first, input and output, then it is common emitter, means I need to connect two emitters here. So here is one and another is for base side. Okay, so the current gain, that is denoted as beta, equal to output current by input current. So base is common, leave it, output current is IC, input current is IB. Okay, so the voltage gain is output current into so output voltage by input voltage, so IC into R0 divided by IB into RI. So this is the voltage gain for common emitter. Now coming to voltage gain for, so this is the common collector configuration, where base and collector are common. So collector is connected to the input and emitter is connected to the output. So it should, so you should know that, so if I connect collector to this side, then both the collector terminal will become on the one side. So this should not happen. Collector should be common, means it should be in input as well as output. So if I connect this way, then base is fixed here, so collector emitter I need to connect here itself. Okay, so at that time only this logic will fit. So the output current gain, so that is current gain is given by output current, that is IE divided by input current. So collector is common here, leave it, don't consider. So output current is IE, input current is IB. So voltage gain is output voltage by input voltage, so IE into R0 divided by IB into RI. So you need to just multiply with output resistance and input resistance. Okay, so in this case the output resistance will be RE and input resistance will be RB, because input terminal is base and output terminal is collector. Okay, all right, so this I have just told for theory purpose. So if you remember these three concepts, then you can find out the voltage and current gains, and you can you need not to remember the relation between them. All right, so now coming to next problem. So the next problem is, solve the following circuit, that is they have given one circuit and they are asking VC and VB. So they have given the beta value here. Okay, so this, if you observe, this is a dual voltage divider circuit, old BJT. Okay, so voltage divider means we are provided with two resistances with a base terminal here. So this is the voltage divider configuration, where two voltages are acting simultaneously, that is 20 volt and minus 20 volt. So they are asking to find out VC and VB. So this voltage and this voltage they are asking to find. Okay, now, so as I said, so if this is a Thevenin circuit, then we need so this is the voltage divider circuit. All right, so we need to apply the Thevenin's logic here. So what Thevenin's logic says, so this can be written in this form. Okay, so for base part I will be writing in this VTH into RTH. So this is 1.8 and this is minus 20 volt, so minus plus. So this is minus 20 volt, and they are connected to ground again. This is the ground part. So what it means is we are having a Thevenin voltage VTH and RTH. So this can be written in this form. Now the problem is, how can I find out VTH and RTH? So to find out VTH, if it is having only one voltage, suppose 20 volt, then we will be having only VTH term directly we can find out. But in this case, two voltages are acting, so I need to find out two terms, V dash TH and V double dash TH, where V dash TH is the total voltage when 20 volt is acting alone, and V double dash TH is the total voltage in the base terminal when minus 20 volt is acting alone. So this is just like a superposition theorem which we will be using in network analysis, right? So first I will write a V dash TH, which will be equal to the one voltage which is acting is 20 volt into, so the resistance, lower resistance is 2.2 and total resistance is 8.2 plus 2.2, which will be getting as 4.230. Okay, so this is for V dash TH when 20 volt is acting. So similarly, when V double dash TH will be minus when minus 20 volt is acting. So when minus 20 volt is acting, minus 20 into the opposite resistance is 8.2. So 8.2 divided by total resistance is as it is 8.2 plus 2.2. So which will be equal to minus 15.76. So alright, so therefore Thevenin's equivalent voltage will be equal to V dash TH plus V double dash TH. So when you add these two terms, then we will be getting minus 11.53 volt as the total Thevenin voltage. Okay, so now to find RTH, that is R1 parallel to R2. So these two terms are parallel to each other here, right? So what is the parallel formula? R1 into R2 divided by R1 plus R2. So R1, R2 values just plug in here, then we will be getting 1.73 kilo ohm as the total Thevenin resistance, that is RTH. Okay, so now proceeding in the problem. Okay, so I have drawn the circuit again here. So this is 1.73 is the total Thevenin resistance, and 11.53 is the total that is voltage, Thevenin voltage. So here it should be noted that I have got minus 11.53. So previously it is positive and negative, so I need to inverse the change, that is, so I have made it as negative and positive because it is coming in the negative, means we have to reverse the sign of the voltage source. Okay, so this is the current which is flowing from positive to negative. So this is positive terminal, it will be flowing like this. So from it base to emitter it is flowing. So this is base here, this is emitter, and this is collector. All right, so apply the KVL. So I need to find out the current. So as I said earlier also, if you want to find out the current, we need to apply the KVL at the base terminal. Okay, so applying KVL, what we will be getting? So start from this point, minus IB into 1.73. So we are moving in the direction of current. I will take it as minus IB into 1.73 minus VBE minus 1.8 into, so as I said earlier also, the emitter current IE will be equal to 1 plus beta into IB. Okay, so that's why I have written. So the current which is flowing in the emitter terminal will be IE. So that's why 1.8 into 1 plus beta into IB. So the next voltage is plus 20 volt minus 11.53. So when you come to here, the second sign is minus. So I will take it as minus 11.53 equal to 0. Alright, so I have got the equation. Now substitute the beta value here. So minus IB into 1.73. So our rest all terms will be as it is continued. So 1.8 plus 1 plus beta value is 120. So alright, put this. So we are left with only the unknown terminal is IB here. So rearrange this equation to form the IB equation. So which will be getting as minus 11.53 minus VBE plus 20 divided by 1.73 plus 1 plus 120 into 1.8k. So okay, so plug in the values. VB will be 0.7 value, 0.7 volt. So rest all terms are known. Then when you operate it in calc, we will be getting as 35.39 microampere. So always the base current will be in terms of microampere. So generally it will be in microamperes. So in some cases it goes in milliamps. Okay, so if you want to cross check your answer, make sure that your base current value will be in microampere. So this is the general sign of having a correct answer, right? So now I have got the base current value. So I need to find out collector and emitter currents also. So I know the relation, collector current will be equal to base current into beta value. So beta I know and base current I know. So when you substitute the values, then we will be getting 4.25 milliamps, and emitter current I equal to IC plus IB. So emitter current will be the sum of collector current and base current. So because we know that, so if this is the emitter, then this is base and this is collector, the current which is coming will be equal to the sum of these two currents. Okay, so that's why emitter current will be equal to base current plus collector current. So this is nothing but a BJT here. Okay, so collector current emitter current I have got it as 4.285 milliamps. Now to find out the that is this value, the collector voltage, I need to apply the node analysis to the collector. Okay, so when I apply node analysis to collector, so I want to find out the voltage, that is VC. So what I will do, apply node analysis, that is 20 minus VC divided by this resistance RC, let us say, will be equal to the current flowing through this terminal, that is IC. Okay, so node analysis means two voltages, this minus this divided by this resistance will be equal to IC. Okay, all right. So 20 minus VC divided by that resistance RC is 2.7 into 10 to the power 3 will be equal to the IC. Okay, so thus VC will be equal to 8.53 volt, because I know IC, so plug in the values, will be getting VC equal to 8.53 volt. So now I have got VC. The second term which I need to find out is VB. Okay, so I know the relation VB will be equal to VB minus VE. So previously I have said, if this is the voltage between 2 points B and V, then it will be equal to VB. So this is the difference of VB and VE. Alright, so VB and VE. So therefore VB I can write it as VBE plus VE. Okay, so I need to find, I know VE, so but I don't know VBE, so I need to find out, so I don't know, I know VBE, that is 0.7, so I need to find out VE here. Okay, so apply node analysis at emitter. So when we apply node analysis at emitter, we can find out the VE value. So apply node analysis at emitter. So this is the emitter terminal. So node analysis means, so this is the higher voltage, that is VE, minus lower voltage is minus 20 volt divided by resistance is 1.8, which will be equal to the current flowing through this resistance, that is IE. Okay, so this will be equal to IE. So I have written the same thing here. So VE minus of minus 20 divided by 1.8k equal to IE. So I know that IE is equal to 4.285 into 10 to the power minus 13 amps. Okay, so when I substitute for this IE, here we will be getting VE equal to minus 12.287 volt. So this is the emitter voltage which we will be getting. Now substitute this emitter voltage in equation 1 to find out the base voltage. So I know that VB, that is for silicon transistor, it will be fixed value. So if they are not explicitly okay, so pointing, or they are not, if they have not given the VB value also, you need to assume it as 0.7, because that is the general values which we will be using. So I have taken it as 0.7 plus minus 12.287, so that is VE value. So when you substitute and calculate, you will be getting minus 11.59 volt as the base voltage. Okay, so this is how, if a circuit is given, we need to find out the first collector and emitter and base currents with the help of applying KCL or KVL to the base loop, and then we apply KVL to the collector loop, we will be getting different voltages. So guys, always remember that when you want to determine the current, we need to apply KVL to the base. So KVL to the base, and when you need to find out the current voltages in the circuit, we need to apply KVL to the collector. So this is base and this is collector. Okay, so if you remember that point, then it will become easy to solve the BJT problems. Alright, so now coming to the next problem. So the next problem is solve the following circuit to find VCB and IC. So given beta equal to 110. Okay, so they have given the circuit and they are asking to find out the collector to base voltage and collector current. Okay, so the given circuit is base, emitter, collector. The collector resistance is 4k and it is connected with a 20 volt voltage, and the emitter resistance is 2.6k 2.65k and it is connected with a 10 volt source. Okay, so the voltage between base and emitter will be VB and the voltage between collector and base will be VCB. Alright, so we are moving from base to emitter, so plus minus. We are moving from collector to base, that is plus minus. So the polarity you should make it in your mind. So this is positive to negative, so plus minus. This is positive to negative, so plus minus, not minus, not plus minus in this case, plus minus. So you should know these small things in order to make the problems correctly. Okay, so this is a ground terminal. All right, so first I need to find out the currents. So whatever may be the problem, you just find out the currents, because we will be needing these currents in order to find the voltages. So whatever they will be asking, first apply the KVL to the base loop and find out all these three currents, then go for finding the voltage. Okay, so apply KVL to base. So what is the equation? So starting from this. Okay, so starting from this point, so I am moving in the direction of current, so minus VB, so that is this voltage, minus the current which is flowing in this resistance will be emitter current, because this is emitter terminal, minus IE into the resistance is 2.65k, plus though, so I need to take the second term, so plus 10 volt equal to 0. So when we substitute VB equal to 0.7 volt, then we will be getting IE equal to 3.509 milliamps. So this is the emitter current. I have got the emitter current. Now I know the relation IB equal to IE divided by 1 plus beta. So the normal relation which I will be knowing is IE equal to 1 plus beta into IB. Okay, so when you rearrange this equation, IB will be equal to IE divided by 1 plus beta. So IE value is 3.509 into 10 to the power minus 3. Then the what is beta value will be equal to 1 plus 110. Okay, so when you solve this in calc, you will be getting IB equal to 31.61 microamperes. So this is the base current value. So I have got the emitter current, then I have got base current, then I need to find out the collector current. So this I know that IC equal to beta by IB by beta, so not beta by IB. So we know that beta equal to IC by IB. So IC will be equal to IB, IC will be equal to beta into IB. Alright, so this is the common base configuration, right? So input current by output current, so this is not applied here. So IC equal to IB divided by beta, so this relation we can apply here. So IB is 31.61 microampere and beta is 110, so which will be equal to IC will be equal to 3.4778 milliamps. Okay, so I have got emitter current, base current and collector current. So we should note that here the beta relation which I have applied is beta equal to IB divided by IC, because this is the common base configuration where the output will be base and input will be at the emitter side. So that's why output by input will be IB by IC. Alright, so that's why I'm getting IC equal to IB divided by beta here. Now they have asked to find out the VCB value as well. So VCB they are asking, IC I have already found, so I need to find out the VCB value. So to find VCB, apply KVL to the collector. So this is the collector equation, right? So I will start from this point. So what I will be getting, plus 20. So as you can see here, plus 20 and minus IC into 4K. So plus 20 into minus IC into 4K, that is this resistance, minus VCB. Okay, so starting from this minus plus, so this is minus and this is plus, take second sign, plus 20 minus current flowing through this is IC and resistance is 4K minus VCB, that is this voltage drop will be equal to 0. Okay, so now I got the equation. So solve for VCB. So VCB will be equal to 20 minus IC into 4 into 10 to the power 3. So which will be equal to 20 minus 3.4778 into 10 to the power minus 3 into 4 into 10 to the power 3, so which will be equal to VCB, so 6.12. so when you solve this in calci, you can find it easily, 6.12 volts. So I'm not solving because it will consume lot of time, so the video will become too lengthy, so I don't want to do that. So that's why I am letting this you two guys calculate and cross check whether it is correct or not. So I have done all the calculations, so to my point it is accurate. Okay, so this is how we can find out the VCB and IC when a circuit is given. Okay, so special care should be taken while finding out this relation. So IC equal to IB divided by beta, not beta into IB. So this is for common base, that is for common collector. So that's why I have shown previously the formulas, that is collector base, common emitter, common base and common collector configuration. So if you got confused here, then it will be totally wrong. Okay, so you just need to put some special care while calculating the IC in case of common base configuration. So this is the common base configuration. All right, so we'll move to the next problem. Okay, so the next problem which is given is solve the following circuit to find the, so they have asked to find out collector resistance, collector emitter resistance and stability factor. All right, so they have given R1 R2 that is 90k, VC is 3 volt, beta is 200. All right, so this is again a voltage divider circuit. So whenever there is a voltage divider circuit in given, then we need to consider the Thevenin logic. All right, so first I need to find apply the KVL to base loop. So in order to apply KVL to base loop, first I will try to find out Thevenin's equivalent voltage and Thevenin's equivalent resistance. Then I will apply the KVL to base loop and find out the base current, collector current and emitter current. So once I have got those currents, then I can find out the voltages easily. Okay, so VTH will be equal to V dash TH plus V double dash TH. So this is also so previously we are having minus 20 volt and plus 20 volt. Okay, so here it is 6 volt and minus 6 volt. So apply the same logic. V dash TH will be equal to, the first one acting is 6 volt, so 6 into lower resistance is 90, so 90 divided by 90 plus 90, which will be, and V double dash TH will be equal to V double dash minus 6 into 90 by 90. So these are having opposite sign, and when we add, I will be getting as 0 because these are having opposite signs. So this will be not getting as minus 6 or plus 6, whatever may be these values. So let me find it out for you guys. So I am having 6 into what is 90, okay, divided by 90 plus 90. All right, so 3 I am getting as the answer. So this will be equal to 3 and this will be equal to minus 3. So when I add plus 3 and minus 3, so this will cancel out each other and I will be getting as 0 volt in this case. So that's why I have written it as directly 0 volt. So Thevenin's equivalent voltage which I am getting in this case is 0 volt because these two resistors are equal to each other. So we can conclude directly, when these two resistors are equal to each other and these two voltages are opposite to each other, then the Thevenin's equivalent voltage will be equal to the 0 volt. Okay, so without calculation also you can directly write it as 0 volt. So there is no need to do all those things if you know the trick. So now I need to find out the Thevenin's equivalent resistance, that is RTH. So it will be equal to R1 parallel to R2. So R1 into R2 divided by R1 plus R2. Substitute for R1 R2, that is 90. Okay, so we will be getting as 45k. So this is the Thevenin's equivalent resistance which I have got. Now in this so apply the KVL to the base loop. Okay, so when I apply the KVL to base loop, what I will be getting is, this is 0 volt here, starting from 0 volt. So this I have got it as 0. So 0 into minus IB into 45k. So this is the base current which will be flowing, and it the RTH what I have got is 45k. So minus VB, that value is here VB, so this is 0.7 minus IE into RE, so minus IE into RE plus 6. So this is the last voltage, this is minus and this is plus, so this is plus 6. Okay, so which will be equal to 0. So this is the equation what I will be getting when I apply KVL to the base loop. All right, so here the problem is that I don't know what is the IE and RE value, so I can't find out the IB value unless and until I found out the IE into RE. So how I can find out the IE into RE? So this is simple. So apply node analysis at emitter. Okay, so as I said, when you apply node analysis at this point, it will be equal to VE minus of minus 6 divided by RE, it will be equal to IE. Okay, so that I have applied here. VE minus of minus 6 divided by RE is equal to IE. So what I can write? So I need to find out IE into RE. So I will multiply here. So IE into RE will be equal to VE plus 6. Okay, so I have found I into RE equal to VE plus 6. But again the problem is that I don't know VE. So though I have substitute I equal to RE, which is VE plus 6 here. So I don't know VE, so then I can't find out IB. So I need to find out IB, means I have to first find out VE here. Then only I can substitute I into RE for VE plus 6 and then substitute for VE. So then at the end we will be getting IB. Okay, so to find VE, what I will do, I will use this relation VCE equal to VC minus VE. So that is the voltage between these 2 points. VCE will be equal to the difference of VC minus VE. Okay, so that relation I have used here. So VCE will be equal to VC is 0. So how I am taking it as 0 means, so this is the VC point, right? So it is given that V naught equal to 0 means VC is also equal to 0, because these are so they have just denoted it as V naught, that is actually the collector terminal. So they have given directly. So that is the trick in which we should concentrate in order to solve this problem. So if you don't know how to use that V naught equal to 0 value, then it is very tough to find out solve this problem. So this terminal goes to 0 here because they have given directly in the problem. Okay, so substitute for 0, then we'll be getting VE equal to minus 3 volt, because VCE we have they have given as 3 volt here. So they have given 3 volt as VCE. Substitute VC equal to 3 volt, then we will be getting VE equal to minus 3 volt. Okay, so alright, first we have got VE equal to minus 3 volt, then substitute this in the this equation, that is the equation, let us say second. So when you substitute here, I into RE equal to minus 3 plus 6, so VE value is minus 3 plus 6, then I will be getting as I into RE equal to 3 volt. Alright, so I have got I into RE value here, then I need to substitute in the above equation. So minus IB into 45k minus 0.7 minus, so the value is 3 volt, 3 volt plus 6 equal to 0. So when you rearrange and solve in the calculus, you will be getting base current IB equal to 51.11 microampere. So this is the base current value. So I need to find out again the collector current. So IC equal to beta into IB. So 0.0102 ampere I will be getting. Then at the end IE in terms of base and collector. So when you know base and collector current, so emitter current will be equal to the addition of base current as well as the collector current. So this will be equal to the addition of these two terms. So that will be getting as 0.01027 amps. So it should be noted that the IB current here is in terms of microampere and collector and emitter current is in terms of amperes. So one cross check what you can do to verify your answer is base current plus collector current should be equal to the emitter current. So nearly it should be equal. Okay, so when you add these two terms, I am sure that we will be getting 0.0127 amps. So here you should note that this is in terms of micro, not in terms of amp. Okay, so this is how we can get the currents now. So our main motive is to find RC and RE. So now our actual problem starts from this point here. Okay, so now to find RC, apply node analysis at RC. So I have drawn the circuit again here in order to okay, so it will simplify our work, so I need not to see that page again and again. Okay, so apply node analysis at collector. So this is the collector, that is RC here. So apply node analysis. 6 minus V naught, that is it is connected to 0 directly, it is given in problem, divided by RC will be equal to IC. So this minus this divided by resistance will be equal to, that is the current flowing through this resistance, which is IC. So RC is equal to 6 divided by IC. So IC value I know already. So when I substitute for that, I will be getting RC equal to 586.96 ohm. Okay, so I hope you got the point, that is node analysis, how to apply upper voltage minus lower voltage divided by the resistance. So I equal to what, this is V by R. Okay, so the net voltage is 6 minus V naught, so V naught is equal to 0 they have given, so I have directly taken it as 0 divided by the resistance, that is RC, which will be equal to the current flowing through that resistance, that is IC. Okay, so that will be equal to RC. So when I substitute all those values, then I will be getting as 586.96 ohm. Okay, so now I have got the RC value. So to find RE value, so that is to find this value, again the same concept we will be using, that is nodal analysis. So this value minus this voltage divided by the emitter resistance will be equal to emitter current. So VE, why I have written plus 6 is VE, that is upper voltage minus lower voltage divided by RE will be equal to IE. So minus minus becomes plus, so that's why I written directly it as plus, divided by the emitter resistance is RE, which will be equal to the emitter current, that is IE. So I know RE, I know VE, so I will substitute for VE and RE, then I will be getting IE, that is IE will be equal to 292 ohm. Okay, sorry, so this is RE. IE I know, VE I know, so I need to find out RE, so that's why I written RE equal to 292 ohm there. So I have got RC, I have got RE. Now to find the stability factor, so this is the standard equation which will not change for any problem. You just remember this formula, you can find out the stability factor easily. So that is something by something, which is 1 plus beta divided by 1 minus beta into minus RE divided by RB plus RE. So this is the formula. So just plug in all the values, that is beta, RE and RB, and find it in calci. You will be getting it as 87.797. Okay, so note, make sure that you don't write any unit for this, so because the ohm value which will be getting here will be cancelled out. Okay, so this term will go on the other side, that is numerator side, and it will be having ohm as its unit, and the denominator is also having ohm as its unit. So this ohm and this ohm cancel here, so that's why we will be not left with any that is unit for the stability factor. Okay, so now moving to the next problem. So the next problem which is given is design the voltage divider circuit. So they have given the voltage divider circuit and they are asking to find out some values, that is R1, IB, IC, beta and RC. So they have provided with us alpha equal to 0.985, VC equal to 6 volt, VB equal to 0.2, I equal to 2 milliampere. So this is the given data, this we need to find out, and this is the circuit. So this is, as you can see, this is the voltage divider circuit. So first what I will do, I will find out the alpha with the help of, so I will find out the beta. So they have given beta, right? So beta equal to alpha divided by 1 minus alpha, this relation I know. So when I substitute for alpha values, I will be getting it as 65.67 as the beta value. So alright, so I have found the beta value here. So in the second term I need to find out the current. So I will try to find out first the collector current. Okay, so what I will be getting, IB equal to 1 plus beta into IE. So this relation I know. So what I will do, 2.99 into 10 to the power minus 5 I will be getting, so I know beta value. So 1 plus 65.67 into IE value they have already given here, 2 milliamps. So substitute for beta and IE in the IB equation, then we will be getting base current is equal to 2.99 into 10 to the power minus 5 amps. So this is the base current which will be flowing in this circuit. So now I have got the base current and I know the emitter current, so I can find out the collector current easily. So this is the common emitter configuration for beta will be equal to IC divided by IB. So IC will be equal to beta into IB. So beta value is 65.67 and IB is 2.99 into 10 to the power minus 5. So when I substitute and calculate it in Casio, then I will be getting as 1.97 milliamps. So this is the total collector current which will be available in the circuit. Alright, so I have got IC, I have got IB, and I know IE already. So this means I have got all the currents in this voltage divider circuit. So the left work is to find out the resistances, that is RC and R1. Okay, so KVL to collector. So I need to find out the resistance, that is this RC value. So what I will do, I will apply the KVL at the collector current. So apply KVL to this side. So 16 minus IC into RC minus 6 will be equal, minus IE into RE will be equal to 0. So what I have done, 16, so current flowing through RC is IC, so IC into RC, and the voltage VCE minus VCE, so they are given as 6 volt, so minus 6 volt. So the current flowing here will be equal to IE, so the current flowing here will be equal to IC, because this is collector terminal and this is the emitter terminal. Okay, so current is IE and resistance is 1K, and which will be equal to the 0. So this means I have applied KVL from this point to this point. So this is the path which is followed. Okay, all right. So when I substitute for IE, because I know IE already, and RC will be equal to the 4.06 kilo ohm, because I don't know RC here, I know IC, I know IE. So substitute for IC and IE, I will be getting RC equal to 4.06 kilo ohm. So this is how you can find out the collector resistance, that is RC. So I have found out RC also, and I have found out beta, and I have found out IB. I am only left with R1 value here. So to find R1, let us see what should be done. Okay, so to find R1, apply Thevenin's logic again. So as this is the voltage divider circuit, so whenever there is a voltage divider circuit given, we need to find out the Thevenin's logic. Okay, so what it will be, VTH, RTH, and the other rest of the things, that is 1K, the current flowing through 1K is IE. Okay, so these things will be there. So how I can find out VTH? This will be equal to 16. So here it should be noted that only one voltage is acting. So in the previous videos or previous problems which we have solved, there are two voltages acting. So my plus 16 and minus 16, minus 4 and plus, so something like that we have solved, right? So in this case only one voltage is acting, that is positive voltage, and negative voltage is equal to 0. So in this case our work is simplified, because we need to consider only the one voltage here. So VTH is equal to 16 into R2 divided by R1 plus R2, so that is 30K divided by R1 plus 30K. So they have given R2 value, but they have asked to find out the R1 value. So put R1 as it is. Okay, so put R1 as it is here. So RTH will be equal to R1 parallel to R2, that is R1 into R2 divided by R1 plus R2. So this will be equal to R1 into R2 value they have given as 30K. So substitute 30K. So R1 plus 30K. So I have got VTH and RTH in terms of R1 and some constant values. Okay, so I can't solve them directly, so I need some other equation where I can put this VTH and RTH and solve for R1. Okay, now apply to KVL. Apply KVL at the base loop. So when I apply KVL, minus IB into RTH, so start from this point. So this is all right. So this is emitter, base, collector. Okay, so the current which flowing through this is IB, so I have denoted already here. So this is positive, means the current will be flowing like this. So electrons will be emitted from this point, then they will be collected as this anode and cathode relation. Okay, all right. So minus IB into RTH, so start from this point, minus IB into RTH minus VBE minus IE. So IE I can write already, I have told, 1 plus beta into IB into resistance is 1K plus VTH equal to 0. So that is this drop. So I have got the base equation, that is this equation. Okay, so rearrange this equation, because I need to find out the R1 here. So I know the relation for RTH and VTH. Okay, so I can find it out IB. So I know the IB value, so I will take on this side. So IB will be equal to VTH minus 0.2 divided by RTH plus 1 plus beta into IK. So I equal to V by R. So in short we can write there are two voltages acting, VTH and VBE. So VBE they have already given as 0.2. Okay, so this is the difference of this voltage and this voltage divided by the sum of all the resistances, that is RTH plus 1K. So for 1K we will be multiplying with 1 plus beta, because we know the relation IB equal to 1 plus beta into IE, or IE equal to 1 plus beta into IE. So this is IE equal to 1 plus beta into IB. So that's why I need to multiply with the IB, or else we can generally use this equation and rearrange the terms so that you can get find it for IB. So VTH I know, RTH I know, so substitute VTH and RTH here. So 30k divided by R1 plus 30k minus 0.2 divided by R1 into 30k divided by R1 plus 30k, which will be plus 1 plus beta into 1k. So I know IB, I know all other terms, that is beta, and these are all constant. So one thing which I don't know is R1, and that only I need to find out. Okay, so R1 will be equal to 139 kilo ohm. So now stability factor is given by S equal to 1 plus beta divided by 1 minus beta into minus RE divided by RB plus RE. So which will be equal to 18.64. Alright, so this don't have any that is unit, we already know. So this is directly calculated as 18.64. Alright, so this is how we can follow the following problem when they are asked to find out R1, IB, IC and beta RC values. Okay, so now moving to the next problem. So the next problem which they have given is